we're getting ready to do lesson 4.2 part 1 of pre-calculus math today, the unit circle. Here is my email if you need note-taking guides, other videos or PowerPoints or any other course. 4.2 trigonometric functions, unit circle, part 1. We got 36 points here of classwork, and we got 4 points today in notebook taking, which is not that bad. And teachers, here's today's bell work. We have to sketch the graph of this, and then the graph of the function here of g of x, and then describe the transformation from f to g. Describe the transformation there, students. Give your students about 6 minutes for that. Okay, welcome back for our solutions to today's bell work. Up here, 2 minus x cubed. Then down here, the negative of x plus 3 cubed. So up here, the graph of g is a reflection in the x-axis. So here is your f of x is x cubed. That's that one. And this one, it's a reflection in the x-axis and a vertical shift 2 units up. So we go 2 units up, and it's a shift in the x-axis here. And then down here we have the graph of g is a horizontal shift 3 units to the left. So we do this jog over here at 3 is our intercept there of the x-axis, and a reflection in the x-axis of f of x equals x cubed. So this is the negative of x plus 3 cubed. We have this general downward slope here. This is your slope there. Same thing up here. This is our slope here is -1 for this downward sloping. Okay, into our lesson today, page 1 on your class worksheet, the unit circle. The 2 historical perspectives of trigonometry incorporate different methods of introducing the trigonometric functions. Our first introductions to these functions is based on the unit circle. Consider the unit circle given by x squared plus y squared equals 1. So when we have that here, x squared plus y squared equals 1 here, this is your unit circle that is the origin of this expression here. Imagine that the real number line is wrapped around the circle with positive numbers corresponding to a counterclockwise wrapping and negative numbers corresponding to a clockwise. So we have a counterclockwise wrapping, and then negatives are a clockwise wrapping as shown here. So here's our unit circle here. So we just wrap our number line, say, around your circle like that. Then down here is your negative. Your negative values start here at the origin at 1, 0, and they go this way on our unit circle here. Okay, students, this goes in your notebook. As the real number line is wrapped around a unit circle, each real number t corresponds to a point. So each real number corresponds to a point xy on the circle. For example, the real number 0 corresponds to the point 1, 0. Because the unit circle has a circumference of 2 pi, the real number 2 pi also corresponds to the point 1, 0. So in general, each real number t also corresponds to a central angle theta in standard position, whose radian measure is t. With this interpretation of t, the arc length formula, s equals r theta, with r equals 1, r is a radius, indicates that the real number t is the directional length of the arc intercepted by the angle theta given in radians. So there's a lot of information there. Students, make sure this goes in your notebook. I do notebook checks on Friday, so make sure it's done by then. You can view it on YouTube or PowerShell. The trigonometric functions preceding discussion, it follows that the coordinates x, y are two functions of the real variable t. You can use these coordinates to define the 6 trigonometric functions of t: sine, cosine, tangent, cosecant, secant, and cotangent. These 6 functions are normally abbreviated like this, and definitions of trigonometric functions. Let t be a real number, and let xy be the point on the unit circle corresponding to t. So t is a symbol here for positions on your unit circle, and then these functions are how we comprise different kinds of calculations of this point on the unit circle. And this goes in your notebook. Again, an important slide. Sine t equals y, cosine t equals x. Then tan t is y over x, so it'll be sine over cosine. Then cosecant t be 1 over y. Then secant t be 1 over x. Cotan t equals x over y. So in the definitions of the trigonometric functions, note that the tangent and secant are not defined when x equals 0. For instance, t equals pi over 2 corresponds to x, y, which equals 0, 1. It follows that the tan of pi over 2 and secant pi over 2 are undefined when you have this coordinate situation here, because you'll have a 0 in your denominator. Similarly, the cotangent and cosecant are not defined when y equals 0. For instance, because t equals 0 corresponds to xy, like when your y is 0 here, like it is here, cotan 0 and cosecant 0 are undefined. So you can't have 0 in your denominator for these functions to be defined. Okay, the unit circle has been divided into 8 equal arcs corresponding to t values. So here are your 8 equal arcs here. So your circle is divided up into 8s here. And then these are your xy coordinates here, xy, 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 of your measurements here. So 0, pi over 4, pi over 2, which is here, just pi over 4. And then 3/4 pi is here, then pi. And then 5/4 pi, 3/2 pi, and then 7/4 pi. Excuse me. And then 2 pi is here. The unit circle has been divided into 12 equal arcs, so now we have 12 equal arcs here, and then their corresponding t values are here as well. So now it's divided up into 12s. So you have 1, 2, 3, 4, 5, 6 up here, and then down here as well. And then here are your radian measures of a unit circle divided up into 12s. Okay, first example. Evaluating trigonometric functions. Evaluate 6 trigonometric functions at each real number. So we have pi over 6. So for each t value, begin by finding a corresponding point, xy, on a unit circle. Then use the definitions of trigonometric functions. So up here, for a square root of 3 over 2 and 1/2, t equals pi over 6 corresponds to this point here, x and y. So x is square root of 3 over 2, and then your y is 1/2. So here is your x value here, and then your y value is 1/2 here on your unit circle. It's 1/2 of the way up on your y-axis, 1/2 of a radius. So sine pi over 6 equals y, which equals 1/2. So the sine of pi over 6 equals 1/2. That is your real number value of pi over 6, which is here. And then the cosine of pi over 6 is your x value, which is the square root of 3 over 2. Okay, so moving along in here, we have this point here on the unit circle, and then our functions here, pi over 6, which is this point here, with your coordinates, your xy coordinates here, and then 1 over x would be secant would be pi over 6, which is 1 over x. So that would be 2 over the square root of 3, and then we rationalize our denominator, in which we end up with 2 times square root of 3 over 3. And then cosecant would be 1 over y, which is 1 over 1/2, which is 2. And then our tan would be y over x. So we have this situation here. By the time we rationalize our denominator, we end up with square root of 3 over 3. And then cotan of pi over 6 would be x over y, and we get square root of 3. Now, b would equal t equals 5 pi over 4. So t equals 5 pi over 4 corresponds to a point of negative 2, and the negative of square root of 2 over 2, and then the negative of square root of 2 over 2, which is this point right here on your unit circle. So the sine of 5 pi over 4, which equals y, would equal a negative of square root of 2 over 2, which is this coordinate here. And then cosecant would be 1 over y, which would be just negative a square root of 2. Okay, finishing up here for 5 pi over 4 with our 6 different functions here. We have cosine 5 pi over 4 equals negative of square root of 2 over 2, and then the secant of turns out to be the negative of square root over 2, and then tan square root of 2 over 2, negative square root of 2 over 2, which equals 1. And then the cotan would be the reciprocal of this, which would equal 1 as well. Then moving on to pi here, which is negative 1, 0. Our coordinates for pi are trig functions for that. Sine of and then those turn out to be, when we figure our functions here, secant would be 1 over x, would be 1 over negative 1. Cosecant would be 1 over y, and then tan would be 1 over x, would be 0 over negative 1 over 0. And then cotan of pi would be x over y. This flips that around, so it would be undefined. Now moving on to moving clockwise around the unit circle to the negative of pi over 3, which would be a negative 60 degrees trig functions for that would be the sine of negative pi over 3 would be negative square root of 3 over 2, and then cosecant would be negative 1 over 3, 1 over this, so you reciprocate this, and then you rationalize your denominator, square root of 3, and cosine negative pi over 3, which will be your x equivalent here, would be 1/2, which here will be your x squared, would be 1/2, and then the secant of negative pi over 3, which will be the negative that up for secant. And then for negative, rather the tan of negative pi over 3 be y over x. So that would be square root of 3 over 2 and a half comes out to negative radical 3. And the tan would be the reciprocal of that. 1 over negative 1 over square root of 3, and then you rationalize your denominator and you come up with the square root of negative square root of 3 over 3. Into our practice now. I'll do this one for you. This is unused. So up here, t is 3/4 pi. So 3/4 pi on your unit circle corresponds to here's your x and here's your y coordinate. So for our sine, which is our y here, would be the radical 2. Our cosine would be our x coordinate, would be the negative square root of 2 over 2. And 1 over x, and that comes out to negative 1 here for our tan. And our cotan would be the reciprocal of that. We're going to go to cosecant now, which is 1 over y, which is 1 over square root of 2 over 2, which comes out to be square root of 2. And then secant would be 1 over x, which would be this situation here. We reciprocate this, and this comes out to the negative of radical 2. And then here is our cotan, which is x over y, and that comes out to being negative 1. And those are your 6 trig functions.